Hello, Hornets, and welcome. It is Mr. Lamb again, and we are going to be talking about the FRQ 2002 Form B, number 6. And with this FRQ, what we're actually looking for is we're trying to just practice related rates and, frankly, get used to the idea of what an FRQ is. So let's just take a look. A ship is traveling due west towards the lighthouse rock at a speed of. Notice they use the word speed. Now we already know that speed is the absolute value of velocity, so the sign has disappeared. And for us, we have to know what that sign is in order for us to work with related rates. So the way it works is, if the distance is getting smaller, so I'm heading towards the lighthouse rock, I have a negative velocity. If I am moving away from Lighthouse Rock, where the distance is growing, that is a positive rate. So we have 15 kilometers per hour moving towards, so we're looking at a negative 15 kph. Ship B is traveling due north away from the lighthouse, so we're looking at a positive 10 kph. And we're looking at the distance x is the horizontal, and the distance y is the vertical. Now, they tell us to find the distance in kilometers between the ships when ship A is at 4 kilometers from Lighthouse Rock and ship B is 3 kilometers. Now, I recommend that if you don't have a picture, that you draw one. Luckily, the AP test is most likely going to provide you with a picture, but we still have to be prepared. So I have 4 kilometers here. I have a right triangular relationship. I have 3 kilometers here. I know that this rate, being the y value, is going to be 10 kilometers per hour. And I know that this rate is a negative 15 kilometers per hour. Now, the first question asked us to find what this distance here is. And to do that, we're going to have to use the Pythagorean theorem. Now, if you know your Pythagorean triplets from your geometry, then that will help you. Because this is a 3, 4, 5 triangle, and therefore I know it has to be 5 kilometers. If I'm using the Pythagorean theorem, x squared plus y squared equals z squared, which is going to leave me with 4 squared plus 3 squared equals z squared, which is 16 plus 9 equals z squared, which is 25 equals z squared, and I take the square root on both sides to get the 5 kilometers, and that is z. So our first question can be answered very quickly. The distance between the two ships is 5 kilometers when ship A is 4 kilometers from Lighthouse Rock and ship B is 3 kilometers from Lighthouse Rock. Find the rate of change in kilometers per hour of the distance between the two ships. Well, that's z prime, and it forces me to use the Pythagorean theorem again. X squared plus y squared equals z squared, which means that I have 2x x prime plus 2y y prime equals 2z z prime. I can get rid of all of the 2's. Since everything has a 2, I can divide by 2. And then because I'm trying to solve for z prime, all I have to do is plug in z. And once I have all of that information, everything I have is here. So I'm going to be putting my 4 times negative 15, make sure you have your negative, plus 3 times 10 divided by, and now I have my 5. This is z prime. Now, please be aware, if we wanted to use z prime, we're going to have to find it. If we choose not to use z prime, we don't have to. However, I will point out that they both have a 5. So I'm looking at 4 times negative 3 plus 3 times 2, and I have divided by 5, leaving me with negative 12 plus 5 is negative 7 kph. Now, the last question on this said, let theta be the angle shown in the figure. That's right here. Find the rate of theta, rate of change of theta. So at what rate is theta changing in radians per hour at the same moment? Now, as I mentioned in class, for those of you who have forgotten, I can use any function. If I decide to use cosine of theta, I have to make sure that I use the appropriate ratio, which is going to be my adjacent over my hypotenuse. That would require me to now use implicit differentiation for minus sine theta, theta prime equals x prime z minus x z prime divided by z squared. And now I'm going to use the information that I found already. I know z prime is negative 7 kph, kilometers per hour. I know k is 5 kilometers per hour. I know x, I know y, I know x prime, I know y prime. So let's assume for the moment that I wanted to use sine of theta. Sine of theta is now going to be y over the hypotenuse. So I have cosine of theta times theta prime equals y prime z minus yz prime all over z squared. Now, the third option that I would think is reasonable is the tangent. And frankly, the tangent is what I would use. The reason is because they have given me the information and I can use their information as opposed to anything I found. After all, if I found it wrong, I'm going to lose credit and I want to make sure I don't. But using the tangent allows me to work with my y divided by x, which then becomes secant squared of that theta times theta prime is equal to y prime z minus y x prime, y prime x, and then y x prime all over x squared. Now we know what our secant ratio is. It has to be the hypotenuse 5 over the adjacent side 4, which is going to be 5/4. Now it's squared, and I've got theta prime. I'm going to put all of my information in. We have a 10 times 4 minus 3 times negative 15 divided by 4 squared. And when I take my reciprocal, the 4 squareds are going to cancel, leaving me with a 5 squared in the denominator. So my answer for theta prime is going to end up being 40 plus 45 divided by 25. Now we can clearly see that's 85 divided by 25. And if I wanted, I can reduce. I know that I'm looking at 35, so that's 17/5 is the rate of change in radians per hour. And that's my answer. So this was our first example of an FRQ. I hope that it made sense for you and that I was able to kind of show you and relate what we're doing, as well as to show you that you have many different choices for C, and it all depends upon what you want to do. That's what I have for you today. Thank you very much. I hope that this was useful, and please leave some comments if you found there was a problem to it. Thank you very much. Take care, and please be safe. Remember, it's easy to be mean, Hornets, so please work harder. Change starts from within. Thank you.